Good afternoon, all. Hey, Marie, how you doing? Ophelia, how are you?
Hi, sir. I'm here.
Nice.
Good
Were you
afternoon,
able?
sir.
Were you able to check the YouTube to see if you get the stuff?
Sir,
Sir, I checked it.
I
I
don't check
only
it
see
yet.
one. I only see one, sir.
You only see one?
Yes, sir. The one that I post in the group. That is the only one I'm seeing.
The one that what?
I post in the chat.
Oh, you post. I didn't even see that you post one in the chat. All right. So I did them all. So I have to go back and look at
Oh,
the. I have to go back and look at the settings because um you know when the others come, I'll just project it. I'm actually. But were you able to get the any revision done up?
me, sir?
Yeah, were you able to get any revision done up?
Honestly, sir, no, because we're working on a line.
Mm, okay, all
Sir,
right.
sorry.
You're breaking up, don't worry.
Okay. I don't know what's happening.
All right. All right. I'm gonna look back at this stuff and and then rejoin. Not rejoin. Sorry. I'm gonna give the others a few to come in.
So
All
you
right.
could just go and look at it. So you could just go and look at it now, sir.
Yeah, that's what I'm saying. So I'm gonna look at it while the
Yes,
others
sir.
are getting
Getting
themselves ready
ready
for
to come
class.
in.
Right. Yeah, man. Cool.
Yes, sir.
Cool.
All right.
Good evening, sir. Good evening, everyone. Sir Shand?
Good evening.
Good
Sir,
evening.
I'm going to check on the recordings.
Okay. All right. Thanks.
All right, guys. I'm back with you. Um, not very many of you are here. It's now 15 minutes past. I really need to go. Marie, everything is good to go now. So you can. Oh, I just see the message, Marie, to say that they're all here there now. Yeah, yeah. Okay, so let us begin. I don't think I'm gonna start. I know I have the logarithmic function to do, having done oh Lord Jesus, this I never did the exponential. All right, what I have to do today is I may have to go through the exponential function if I have not done that with you, and I'm going to go through the logarithmic function if I have not done that with you. But I'm not under the logarithmic function, but for sure.
Sir,
Yeah.
good evening, sir. Just to confirm, no, you haven't done either one of those with us. Remember, we missed some classes. So we are far behind and we are moving at a snail's pace, unfortunately for us. So I understand the urgency, sir, and I'm willing to try.
Yeah, man. So thanks for the support. Yeah. So I missed one class, and then we had the student meeting. So those are the two classes that she's referring to.
Yes, sir.
So I know I have the exponential and the logarithmic, but I have been spending quite a bit of time on the differentiation, and I want to take a break from the differentiation into some other areas. I'm a little bit worried at this point in time, if I'm to be honest with you. I'm not even worried about the mid-semester because I've covered the areas a long time for the mid-semester. I'm just a little worried about the pace at which we're moving to cover the other areas. So as soon as this system comes up, we are going to be moving, we're going to go back to our, matter of fact, I'm going to start and finish the stationary points today. Stationary points, okay, so let me just go through something while this thing comes up. So stationary point, I'm starting and finishing stationary point today. And we're going to get a lot of questions to do. I understand that you have a lot on your plate. So when I give you extra work and handouts to read through, oftentimes I come to class and you're honest students and you will confess to me that, sir, didn't get a chance to go through. So you always have work to do for me, but you no need to catch up on those areas that you must. In previous semesters, I'm able to cover the whole syllabus, including the summer semester. So I really don't want this summer we're not able to do it. So guess what? When we're doing a stationary point question, we first differentiate the function. When the function is differentiated, we're going to set dy by dx equals to 0. We're going to set dy by dx to be equal to 0. So when we get a stationary point question, we first differentiate the function. So if the question is given as y equals, we're going to find dy by dx. If the question is given as f of x equals, we're going to find f dash of x. If the question is given as g of x equals, we're going to find...
Sharing something?
Say it again, JJ?
Supposed to be sharing something?
Not sharing yet. My system is warming up.
Oh, okay.
Yeah, but what I'm talking about, I've already typed for you guys. So we just, as soon as it comes up, I will just project it. So if the answer to find, if they give the function as g of x, find g dash of x. If they give you h of x, find h dash of x. So remember, when they give you as y, you're going to find dy by dx. When they give you as any other variable of x, you're going to find that variable dash of x. All right. So when you find a differential, you're going to set the differential equals to 0. When you set the differential equals to 0, you're going to be solving for the unknown. Now, sometimes you may get one value. If it's a linear function, you will get two values. If when you differentiate it to get a quadratic, you'll get two values. When you differentiate the function and get a trinomial of degree n, you're going to get n values. All right? And when you get those values, you're going to be called critical values. And those critical values will be substituted into the original function. The original y or the original f of x. The original y or the original f of x. To find the corresponding y value. Now the x value and the y value together will give me my point. Will give me my point. And that's what we wanted to find, the critical point. That's it. I kid you not. It's one of those areas, if you know how to differentiate, it is so much easier. This thing is taking quite a while to come up. I didn't even realize that it was. That it was fully dead. But anyhow, so when we get the function, we differentiate the function, we set the function equals to 0, and we solve for the unknown. Unknown or unknown. Sometimes you will get an unknown, but many, many more times you'll be given unknowns to solve for. As many of the unknowns that you solve for when you set dy by dx equals to 0, you're going to be substituting those calculated values, which is what we call critical values, into the original function to obtain the corresponding values. Now, the pair of those numbers will give me my critical points. Now, my critical points must determine the nature of those critical points. So what do you mean by nature? Nature means either it is a local maximum, a local minimum, or a saddle point. We're not so geared for saddle points at this stage. We're geared mainly for the local maximum, local minimum. So we're going to be looking for those values that are local maximum, those values that are local minimum. So remember, so in order to find the local maximum, local minimum, we are then going to now find the second derivative. What do you mean by the second derivative? The second derivative is really the second differential. The second differential. So once I differentiate the function once, in order to find the second differential, I'm going to differentiate dy by dx one more time to get d squared y by dx squared, or I'm going to be differentiating f dash of x once more to get f double dash of x, or I'm going to differentiate g of x one more time to move from g dash of x to g double dash of x. Similarly, if you're given h of x and I differentiate it once and I get h dash of x, when I differentiate it the second time, I'm going to get h double dash of x. What's the point? You have to differentiate the function twice in order to get the second derivative. And when I would have calculated the second derivative, what I'm going to be then doing is setting the second derivative, looking at my second derivative, substituting my critical points into the second derivative, substituting my critical points into the second derivative. No, if when I substitute the critical points in the second derivative and my answer is negative, it says to me that I have a local maximum. It says to me that I have a local maximum. When I substitute my critical point into the second derivative and I get a positive value, it says to me that I have a local minimum. If when I substitute my critical points and I get 0, it's going to say to me that I have a saddle point. But as I said before, saddle point is not really on your syllabus, but I'm telling you nonetheless, should in case you do something and get a 0, you can tell them saddle point. So you will see 1 or 2 of the questions that I'm going to project in. I'm still waiting on the system to come up, but I'm just going through what it is that you're supposed to be doing. Now, so that's how you're going to be classifying. So the question will say, classify the critical points. That's one way of saying it. Another way of saying it would be determine the nature of the critical points, right? So when you determine the nature of the critical points, the question is asking you whether it is a local maximum, a local minimum. when they ask you to determine find the classify, the classification is the same thing as determining the nature. So it's just one of two things. One of two things. All right. And then one of the third things that they could ask you to do is to determine the point of inflection. Notice I said inflection, not infection. All right. So the point of inflection is simply by finding the second derivative and set it equals to 0. But sir, we would have already found the second derivative in order to classify the nature of the critical points. Excellent. So what we're now required to do is just to set the second derivative equals to 0, calculate the value or values of x there, and then what we do now is just substitute it into the original function again. We go back into the original function again. And when we substitute it into the original function, then we are going to be getting the y value, or the f of x value, or the g of x value, or the h of x value. And that now will give me the point of inflection. And I will show you what the point of inflection is when we're looking on a graph. Similarly, they could ask you to find the x-intercept and the y-intercept. Now remember this from a long time. The x-intercept is found when y equals 0, and the y-intercept is found when x equals 0. Notice this. If you didn't see this before, watch this. To find the x-intercept, it means that the other one is going to be equal to 0. So the x-intercept, it means that y is equal to 0. The x-intercept, it means that y is equal to 0. The y-intercept means that x is equal to 0. What's the point? I can't ask you to find the x-intercept and put x equals 0. That's a no-no. Right. So if you find the x-intercept is the other one that is going to put into 0. So if you can remember that concept, there is no way you can get the x-intercept and the y-intercept business incorrect or mixed up. So again, for those of you who don't catch what I'm saying, oh Lord, now that it's coming up, it's telling me that Zoom is updating. Jesus. Anyway, let's continue. So to find the x-intercept, y is going to be equal to 0. And to find the y-intercept, x is going to be equal to 0. And then guess what? The last part of this question, they will answer to sketch the graph. The last diggy part of the question is to sketch a graph. Now, so all of what we would have done, finding the critical points, determining the nature of the critical points, finding the point of inflection, finding the x-intercept and y-intercept.
Sir, the point of inflection would be like a mirror effect, correct?
Very good.
Because I'm remembering from pre-calculus when I was doing that, I had to find the opposite. That's what I use in the back of my mind. I call it the opposite, the inflection, meaning the opposite. So wherever the point was below, like you fold a paper in half, where it touched that part, that's where the other one would be on the graph paper.
Yeah. All right. So it won't touch it, but it's a mirror line.
That's what I was saying.
Right.
So what is on the y-intercept or on the x-intercept, if you fold it over that section, that's where it would coincide.
Yes-ish. And I'm going to show you. Yes-ish.
All right.
Yeah. But you have an idea of what it is that I'm talking about. Great.
Yes, sir.
So so technically, that's what it is that we're about. So all those 5 things you're going to be required to put on a graph paper. Not a graph paper, I'm sorry. I'm very sorry. No graph paper, it's a sketch. You're not plotting. So the difference between a plot and a sketch, a plot is what you put on a graph paper because you're actually plotting the points.
Sir, I appreciate that. Because if we plot in the graph, I will miss a part, we'll lose mark. But if we sketch it, we're good.
Yeah, man.
Thank you, sir.
If you do the sketch, I know what I'm looking for the sketch. So let us go again. While this thing comes up, let us go again. We're doing the critical points, that's number 1. We're determining the nature of the critical points, that's number 2. We're finding the point of inflection, that's number 3. We're finding the x-intercept, that's number 4. We're finding the y-intercept, that's number 5. So once you're sketching the graph and those 5 somethings, Me can sip on a graph paper? No, come on. No graph paper. On the sketch. You see, I'm programmed. Forgive me, I'm just programmed. I have to remember, okay, so I'm doing foundation concept 3 this summer.
Yes,
So you know those
sir.
students use graph paper because you'd have done foundation 3.
Yes,
So
sir.
I have to be reminding myself of which
Right.
class that
Yeah.
I'm in. So there's no graph paper. If any of you put something on graph paper, now get the mark written up, the question, I'm going to say sketch. All right.
Amen.
So
Yes, sir.
once those 5 something can be sketched on the paper, in your book, yeah, on the paper, not graph paper, but on the paper, you will get those marks. And
sir,
it is, yeah, go ahead.
one of the things that I noticed is that what we learned in Foundation Concept 3 is based on the equation, you can tell what the line is going to look like. In fact, I got quite a few of those questions. So if it's going to be the squiggly one or the same parabola, or this is V looking one and there's another one with a straight line going down, based on the actual equation, you can tell what the line is going to look like.
Very good, because that's why in Foundation Concept 3, what we normally do is teach you the basic graph shapes.
Yes, sir.
So we need to know what the shape of the graphs look like now.
How to
For
make
those
them.
of you who I would have taught Foundation Concept 3, you would see me talk about the straight line graph. You see me talk about the you see me talk
one. Yeah.
the U-shaped one.
Yeah, that one. Parabola.
And then the parabola. And then you hear me talk about the sexy graph. The sexy graph is going to be the X cube graph. Now, the truth of the matter is, the X cube graph mainly you're going to get for the something.
Which one, sir?
The X cube graph.
The X cube? X cube. Okay, so I know what that one look like, sir.
Yeah, man, that's a sexy
I
shape.
remember vaguely what it looked like.
Yeah, man. So in a nutshell, that's what stationary point is. And I'm saying to you, it really not bad. No, no, I think we should. No, I think we should just go. All right. I really hope that you guys are fine. Really just asking that you just stick to it. I know I'm a little concerned with that. You know, you on a whole, the class is not finding as much time to do the revisions. Just to let you know that the recordings are up in the YouTube channel. I had an issue, but the issue was resolved.
I appreciate it, sir.
Yeah, so I when you go there, you'll see all my recordings for not only for this semester, but you see some for previous semesters too. Those are not labeled. The others are not labeled yet. I will go through at some point in time and label it. So anything that says business calculus, whether it's this semester or last semester or whenever time, you can just go through it and just see what is happening. But in particular, though, you look at this one. So what I did for you to separate the recordings, instead of you having to go and start all the recordings, I don't know which is which. I labeled them. Fortunately, I learned how to label it before saving it. Label them as Business Calculus 2021, summer 2021. So you know which ones are for this semester. But when I label the others, you're free to look at the others in there. What I'm going to ask you to do is to subscribe to the channel. And why I want you to subscribe to the channel is that as soon as other videos are posted, you will get that sort of notification. All right, and you know, I want you to use it wisely. No, what I would have done today, guys, is to give you full leverage in terms of having access to all the recordings. Nobody can say, sir, can you resend the recording for me? And which is why I went ahead and created a YouTube channel, because in the past you have students, sir, can you send on YouTube? And those things fill up my phone when I have to walk up and down with it. Many of you have a smartphone, so you don't even have to save the recordings. You just go onto YouTube, put it in. You don't have any data. Some of you have even social media plan on this stuff, and YouTube is a part of the social media plan for some of the companies, for both companies that I'm aware of. So watching the videos really won't eat up your data, and you don't have to eat up any space on your on your um on your phone or your device. You also have access to Edicasoft, and in addition to that, I'm giving you access to my personal notes, and you have access to me. Me don't know what else to give you. I've given you everything now. It's for you to use all of
Yes.
those. I'm gonna do it. Yes, please.
I make you proud, sir.
I'm me for tell you. I'm me for tell you. All right.
Thank you, sir.
No problem, honey bunches. All right. Let us go. I'm gonna do this once more because I really want you guys to get what it is that I'm talking about. So I'm sharing my screen now, and as I share I want you to. I have not yet sent this to you because at the time, could be last week, Thursday, as a matter of fact, when I was determined that I needed to start this topic, I was still going through some differentiation with you. So I didn't want to send you both things. So at the end of tonight's class, I can send something here. So looking at my stationary point, single variable. Sir, why are you so specific about single variable? Is there a double variable or a triple variable? Yeah, we call it a multivariable. So we have single variable stationary points, and we also have multivariable stationary points that we will be looking at. Now, I said this just now, but allow me to go through it once more. I am going through stationary points, single variable today. Once I do one or two examples in this handout of 18 pages, I'm sending the 18 pages to you. Your responsibility is to go through the other examples. I will not go through all the examples in this document. As long as I can go through one or two of them, well, I wouldn't say one or two because I've gone through one already. I'll go through a few of them. But the others that I have not gone through, it's going to be your responsibility to go through them. What I have done, students, is to do the solutions to these questions. Just as a side point, whenever I send you these things and I generate questions or I find questions in a past paper, you know that I always do the solutions. And why I do the solutions and send to you? To give you that sense of pride that you can look at the question and you know how my solutions go. I give you little narratives inside of it to give you explanations as we go along. So I'm saying this to you.
Sir, we do appreciate it, sir. Well, I appreciate it, sir.
Yeah, man. I know the class does, but where I would love the appreciation, honestly speaking, is
in the assessment, sir. I know, and I'm going to get it
right.
as soon as I can.
And also for you to take up these handouts and go through them. So here goes. So I'm saying, just remember from foundation concept that f of x is equals to y. I can choose to name my function f of x, or I can choose to name my function y. Same difference. So when you see them talking about f of x, don't get afraid or nervous at Lord. Them talking about a f of x graph. There's nothing wrong with it. There's nothing wrong with it. It's the same something. Now, when you talk about a graph of y, more people are a little bit comfortable. And the truth is maybe how we teach. We normally teach in x and y. So when students get other variables, them freak out and them don't know what to do because, oh, Jesus, this is q or this is p. No, man, are the same something, man. Right? So don't be worried about, don't get nervous about the x or y, all right? And then now f dash of x, if I'm given f of x, the first derivative of f of x is going to be f dash of x. The second derivative of f dash of x is going, or f of x is going to be f double dash of x, which is what I was talking about. If the question is given to you as y, then the first derivative is dy by dx, and the second derivative is going to be d squared y by dx squared. I'm trying to see if I can, you know how I roll. I try to help you in understanding. And in these handouts, I have many narratives. So let me just try and put something here. I'm still tapping, guys. Just give me half a second that I just clear my thought. Just had a let me put this in a different color to highlight it. Thank you, Lord. I just did a boo-boo a while ago. This is still the first derivative. ST. That's the first derivative. All right. So look at what I just did a while ago. So f dash of x is saying that it is the first derivative. Can you see that? Talk to me.
Yes, sir.
Right. And then no dy by dx is also still saying that it's the first derivative. Dy by dx is still saying that it's the first derivative. And I'm just trying to highlight something here, Ricky, so that you can see second so you can see what the second derivative looks like. I don't want anybody to be taking up the work and be wondering to themselves, what on earth is this? I want you to be able to see that it's the first derivative. I just press copy. And then you should be able to paste. All right. So you see, that's the second derivative. So one is the first derivative and the other is the second derivative. All right. So you're given the first derivative as f dash of x or dy by dx. You're given the second derivative as f double dash of x or d squared by dx squared. Okay. So what I said to you to calculate the stationary point is to differentiate the function f of x, set the differential equals to 0, that is f dash of x equals 0, then solve for the unknown. This gives the critical value or values, right? Depending if it's more than 1. Then we can substitute the critical values into the original function f of x from 1 above, from up here. So the result together yields a stationary point. We can call it critical point. We can call it turning point. All right? And it's going to be written in the x and y coordinate form. So that's a stationary point. That's a stationary point. To classify the nature of the stationary point, we're going to use the first differential, f dash of x, and differentiate it a second time to obtain f double dash of x. Now you tell me, it cannot get easier than this. I have sat down and I have typed out for you the procedure to go through the stuff. So you can't go wrong. And this is why I'm saying I'm not spending more than one class on this thing, because I've done most of the work for you already. So having calculated the second derivative, f double dash of x, as I would have pointed out up here, that f double dash of x or d squared y by dx squared is referred to as the second derivative. I can say the second derivative, or I can say the second differentiation. It's, the same thing pretty much, right? So you hear me sometimes speak of the second differentiation or the first differentiation, or I may just get a little lazy and say the first derivative or the second derivative. It means exactly the same. Okay, so now, having calculated the second derivative or the second differentiation, f double dash of x, I'm going to substitute the critical value or values in the xy form into my second derivative. If the second derivative, when I substitute it, if it is greater than 0, then we have a relative minimum, as I told you before. If the second derivative is less than 0, we have a relative maximum. And if the second derivative is equal to 0, having substituted, then you have a saddle point. All of it is right here, so, right? And I say I'll soon show you all the graphical method, all right? To determine the intercepts, to evaluate the x-intercept, put y equals 0. See this up? It can't be the x-intercept and put x equals 0. It's always the opposite. To evaluate the x-intercept, put y equals 0. And the reverse is true. To evaluate the y-intercept, you get put x equals 0. To determine the point of inflection, when you use the second differential, see now, we don't talk about second derivative here now. We come back to using the second differential and set it equals to 0. That is, your f double dash of x, you're going to put equals to 0. And solve for the value or values of x, of the unknown. You're going to substitute the value or values obtained in one above, in this one here, into the original f of x, all the way up here, so into that original f of x, similar to what it is that you'd have done for the nature of the stationary points. and then you're going to write down the coordinates of the point of inflection. You're going to write down the coordinates of the point of inflection. All right? You're going to write down the coordinates of the point of inflection. Now, please note that the point of inflection occurs between two critical points at the midpoint. Therefore, if the question has just one critical point, then there exists no point of inflection. And I explain all of what is happening here, because there is a limitation to if you're going to go to a higher level calculus. But for now, this works. For now, this works. I will amend this one. I will amend this point. When I look back at it, matter of fact, when we get to the graphs, you will see what I'm talking about. I'll come back to this when I get to the graphs. Soon come back to this one. And to sketch a graph, ensure that all the points evaluated above are indicated on the sketch. All the points evaluated above are indicated on the sketch, and you're good to go. We did this example in class before. Not going to go back to this example. We did that example before, and we never looked at the sketch of the graph. We never looked at the sketch of the graph. And I'm going to pass the sketch of the graph for this one here, and I'm going to go to the second example here now. But before I do the second example, allow me to ask a question. Are there any questions so far?
I'm well late to the class, and I don't know what I missed from what I don't miss.
Yeah, you missed quite a bit. I would have gone through, I don't know what point he came in, but I went through on 2 occasions the methods to go through in doing the stationary points. But nonetheless, fret not. I mean, the handout is going to be available to you at the end of the class.
Okay, and when you do some of the examples, let me even
I
will see.
When I do the examples, this is what I'm talking about.
Okay.
What I also want you to remember, though, or to be mindful of, not just you, but the whole class. Time is against me, and I'm finishing off stationary points in class today. I have to finish it off because there are other areas for me to go through. All right, so I'm going to go through a few examples. What I ensure for tonight's class is that I did quite a few examples in this handout just to show you what is happening. And then you're going to supplement it with Educasoft. and with the recordings for you to go back again. But students, I understand that you have a lot of work, but from class to class, we hear that, sir, I'm going to do it. It's just that I get a little caught up. Yeah, I understand, but guess what? We need to hit the road running now because time is of the essence. Please, let's go. So this example says, given that the function y equals 2x cubed plus 3x squared minus 12x minus 7, we need to evaluate the following. We need to evaluate the coordinates of the y-intercept. We need to evaluate the critical point or critical points. We need to then now determine if the critical point or points is or are maximum or minimum. I need to sketch the graph of y showing all the points. Wow, that's exactly what I just told you that the question is asking us to do. That's exactly what I just went through up here. All of what I went through up here. But painstakingly, I wrote out all the steps, leaving out none, all the steps that will be required up to the point to sketch the graph that you'll be required to do in order to complete the question. Yours is a responsibility now to go and familiarize yourself with these steps. Let me just check something here, guys. I'm just checking on my class participants. I have a few students on Edifasoft that have not logged on even once, and I'm making my point of my duty. Even though I have the participant listing for those persons who would come into my class, and those persons have not, and this is week 7. Yeah.
Sir,
yes, please.
remember I have a challenge. I don't know how to solve it as yet because I don't have a laptop available to use.
Yeah, but the truth of the matter, Marie, me not even talk about you. Me not even talk to you because you come in my class and you participate. I'm speaking about those students who don't participate in class and don't even know them come class, and they're not doing anything on Edifasoft. So I'm going to drop them. Literally going to drop them. So I'm just checking my list to see if the ones that I'm seeing here are the ones that I know and that I have been speaking to. And so far, I'm not seeing any surprise names. Maybe away from Emilio Cole, but all right, I'll speak to him after. All right, let's go. That's example 1. So we're going to be looking at example 2. That's where we're starting on. The coordinate of the y, how do I calculate the y-intercept? Habla me, how do I calculate the y-intercept? It's a question I'm asking. How do I calculate the y-intercept?
The one with MX or something like that, sir, or not that.
No, man, I just told you. How do we calculate the y-intercept?
X equals 0.
Very good. Thank you. Hold on, please. Good morning. All right. Are you hearing me now?
Can you hear me now?
All
Yes,
right,
sir.
good.
May I hear you?
I was actually conducting a class from my cell phone, and so when I logged on to the other system, I had a feedback, so I needed to just convert everything over. Pray to God that this computer now behave itself. I did that only because of the mishap last time in class. Anyhow, let's go. So we are ready to go. So I just asked a question, and the question was, how do I calculate the y-intercept? Yes, I'm going to put x equals 0. So anywhere in the function I see x, I put 0 there to calculate the y-intercept. So it means that it's going to be 2 times 0 cubed plus 3 times 0 squared minus 12 times 0. Sir, this will go to 0, sir. This will go to 0. That all of this will go to 0, sir. So the answer is going to be what?
-7.
-7. Come on. If this is 0, and that's a 0, and this is, you just have -7. So this is what it is that it looks like. So the y-intercept occurs when x is equal to 0. Therefore, y is equal to -7. But sir, we're not in a working node. Hello, this is business calculus. Put in something equals 0. You can get x equals -7. Let me do this one time, so that none of you can say, sir, I never remember how I got it. But technically, that's what it is that we're doing, are going to be doing. 0. All right. So we're putting 0 into the function. Anywhere we see x, we put 0, and what it is that we're going to be left with is going to be the y-intercept, and it's going to be -7. Now the coordinates, it's we're supposed to find the coordinate of the y-intercept, not just the y-intercept, you know. The y-intercept is -7. It wants us to find the coordinate. Now the coordinate is going to be the x value coupled with the y value. So the coordinate is going to be, the y-intercept is formed when x equals 0. So we know say x must be 0. So see here, so 0, -7. 0, -7, and this is going to be my answer. 0, -7 will be my answer. 0, -7 will be my answer. All right. That part wasn't difficult at all. Then it says the critical points. But sir, you did say to find the critical point, you're going to put dy by dx equals 0. You're going to find dy by dx. Then you're going to set dy by dx equals 0. And then when you get the critical values, you're going to substitute it into the original function in order to find the critical points. Let us check to see if those are the 3 steps that we need to move in order to do our stuff. See here, differentiate the function, set the differential equals to 0, substitute the critical values into the original function. Those are the 3 steps. Then it says the result will yield the stationary points, a critical point. So this is what we're going to get. So there are technically 3 steps in order to calculate the stationary point. And SP are called stationary points. Eh?
So why I feel like we do this already?
We started the topic before.
Oh, okay. Come and know me. That's a, you know, one thing with me big head, you know, me not forget something so easy. So I said this seem like but we just remember say they tell me about the same example them or same writings them they tell you.
Yeah man. We started it before. It's just that I had to take a break because I recognized that the differentiation wasn't where it was supposed to be.
Oh, okay.
Yeah. And so I'm back at it now. Good.
Okay,
So let's go. Yeah, no problem, Papa. All right. So we're doing the critical points now. So the critical points, we need to differentiate the function. When you differentiate this function, what do you get? Differentiate this function from it, please, guys. Tell me what you get.
All right. 326. So that 6x squared plus 326, 6x Minus 12x minus 7. All right, so 6x squared plus 3x minus 12x. 6x minus 12x. That is negative 6x. And 6x squared minus 6x. That me I get. Not sure if I'm right. Just I guess that.
All right. I hear your error. I hear your error, and I will address your error. I'm just going to give somebody else a chance to do that. I'm coming back to you because I need to talk to you about that.
Yeah. Okay. I'm just saying this is just ballpark guessing, you know, sir. And I'm gonna write down nothing I do know.
No, and that's fine because I mean I don't expect you to write one anything into your book. I want you to do the differential in your head space. So I'm proud of what it is that you did, but there's something that I need to correct.
Okay.
I need somebody else to help out Emilio here. All right, so let me just go to my list then and call upon somebody. All right, thank you for not responding.
Emilia, what's the answer you got?
6x squared minus 6x.
Okay.
What's your answer?
God. 1 on 1, 2. What? Lie if it's true.
Sir, what about 6x
At
raised to the
12x.
power of 2?
At 12x squared, isn't it?
No, hold on, Emilio.
Sorry, sir. Yes, sir.
Yeah, go to Ricky. Let me hear.
Go ahead, Ricky.
6x raised to the power of 2 plus x minus 2.
No.
No.
Sir, question.
Yes,
When you do the differential, right? Isn't that you put the 3 in front of the 2? Is that one or am I mistaken? As in, as in 3 and you get.
You're not gonna put it there. You're gonna multiply it.
Right, multiply, right? And you get like, and you keep the powers, no?
No, you reduce the powers.
So I have 12x minus 12x minus 7, right? Which is equal to minus 7. I don't know.
Okay.
Minus 7 is, minus 7 is out, you know, because the differential of the differential of a is 0, you know. Right. But the negative 7 is gone.
Janelle, what do you have?
It's not
very good. Very good, Emilio. Very good, but still have some errors there. Janelle, what do you have? Shuttleford, what do you have? Yana, what do you have?
6x squared plus 6x minus 12.
Okay. Joan, what do you have?
Six x squared to the minus 1 plus 12x minus 12.
Sir, good evening. Sir, I'm just listening because I'm on the road.
Okay, thank you, sweetie, for telling me. All right, no problem. Marie, you're not going to follow up on you don't. Tell me what you get when you differentiate that. Marlene, talk to me. Ophelia, you're going to be next. Marlene?
Sorry, sir, I couldn't find the button. 6x squared plus 6 minus 12x minus 6x.
What again?
6x squared plus 12x minus 6.
Okay, all right, thank you.
Sir,
Rick, yes, please.
when you have the 6x squared plus 6x minus 12, right? Can you then put 6x parentheses x minus 2?
Oh, so you're changing your answer? You're changing your answer? Because that's not what you gave me for your answer, you know.
Because, sir, the 6x2 plus 6x minus 12, that can be simplified, couldn't it?
No, man, no. Hold on, no. So you're changing your answer also, Ricky?
No, because I got that, but I simplified it.
No, man, no.
So 6x2.
6x squared.
6x squared plus 6x minus 12. Is that
Okay,
the answer?
So you're saying that is the final answer? Because that's not what they gave me at first, you know. Okay, all right, fine. Bogle, you're also saying that is your final answer, Bogle?
Sir, what did I give you?
What did you give? You gave me this one. You gave me the one that Ricky just gave a while ago.
Sir, I got 6x squared plus 6x minus 12.
Okay, thank you, Tess. All right, good. All right, so let me not go through the rest of the list. All right, now you see, you see why it is important for me to, when I started this topic, for me to stop and go back to the differentiation, because if you struggle with the differentiation, the first part of the question, there is no way you can get the rest of the question right, and a question like this comes for full marks. When you get a stationary point question, trust me, out of 20 marks of the exam, the stationary point question don't come for less than 10 marks. Sometimes it may come for the whole 20 marks. So let's go. Thank you, Yana. You were right out of the bat, first shot. Then I hear Ricky.
Oh, sorry. Never hear what Yana say.
Sir.
Huh? Never hear what Yana say.
2, 3, 6. And you carry down minus 1 from the 3. Then 3, 2, 6. You minus 1 from the 2. So you know that is 1. And you can't put up the 1 because yeah, all that. And then the 12, you take off the x of the 12, and that's how you get it. So 6x to the second power, 6x minus 12.
Right.
Oh yes, so to get it. Oh, that me miss.
Right, and then I heard Ricky, and then saying that he got that piece, and then I hear Bogle making reference to what I have there as the web idea. So, yeah. Yana said, and all that. You see, all this, when I have to catch the differentiation.
No, you know what go on. See, I don't know what go on, sir. The x me still have on the 12, negative 12, you know. That's why we start minus the 6, the 12x from the 6x, you know.
And that's where I'm going to go to you, because I wanted to ask you, if you can have one banana and one apple and cauliflower plum.
No, we never differentiate the 12x, so that's the problem. Just let the 12x stay away.
Because I am saying to myself, I am going to smack this gentleman silly, because how him going to add an apple and a banana and get a plum. But very good. I'm happy that you recognize your error. And this is one of the good things.
We never differentiate 12x, none at all.
Right. And I one of the things that I've always done is to give you an opportunity to make your own error. So you notice I listen to what it is that you're saying, because I want to be able to get into your headspace to see exactly what it is that you're thinking.
Doing right or doing wrong.
Right, and that's why I went through to the class. I know what the answer was, because I could differentiate it while you were talking to me, and then I could see if you were there. And I did not say to anybody, no, you're not correct. I just said thank you, right? Because I wanted the rest of the class to think about it. No, so let's go again with the differentiation. Thanks, Ghana, you were correct. But let's go again with the differentiation. This 3 is going to be multiplied by this 2 to give me this 6. And I'm reducing this power by 1, so it becomes 6x squared. This 2 is going to be multiplied by this 3 to give me this 6. I'm reducing this by 1, so I'm going to get 6 to the first. And Yana say, I know we don't write the 1 up there, so, and all that. Yeah, you know, we don't need to write the 1 up there and all that, all right? And then when we differentiate the negative 12x, you know that, and all that you have a 1 up top here, but you know, we just say negative 12. We drop the x and we say negative 12, right? Because the x is going to be raised to the first power. 1 times negative 12 is negative 12. And when you subtract 1 from the power, you get 0. And remember, anything raised to the power 0 is 1. So when you differentiate the function, you're going to get 6x squared minus 6x, plus 6x minus 12. And that's my partial answer. That's why I'm putting this in blue. Let me just pause right here and say to you, you're supposed to have the differentiation pat by now. Nobody's supposed to be struggling with this thing. How do you differentiate this? Differentiate that. You're supposed to have the differentiation pat. Come on, let's go. So remember, one of 3 things that we do We know having differentiated the function, we know for critical points, we need to put that differential equals to 0. We now need to put the differential equals to 0. Now, hear me out. I don't want to sound like a broken record, but if I have to, I'm prepared to do it. If your differential is wrong, you're going to have a challenge factorizing the something. If your differential is wrong, you're going to have a challenge factorizing. So hear me out. I'm going to work on the differentiation for a minute, please. Work on the differentiation. I can't accept any excuses now. At the expense of running behind, I spent 1 whole week extra on differentiation. Last week, Thursday, and Tuesday of this week. So I can't give them more time on that. I have to move. So please, you have to work on your differentiation or else you are going to be in serious problems. Let's go. So I'm now setting the differential equals to 0. So what I'm setting is 6x squared plus 6x minus 12 equals 0. See to yourself? 6x squared plus 6x minus 12 equals 0. I am dividing through this equation, 6x squared plus 6x minus 12 by 6. Sir, why? We did this division to make the function easier to factorize. We did this division to make the function easier to factorize. So when I divide through by 6, I'm going to get x squared plus 6x, x squared plus x minus 2. Sir, do we have to divide? The answer is no. But watch me. In order to factorize this trinomial, you'd have to now multiply 6 by negative 12. You can get negative 72. If you want two numbers, when multiplied together, give negative 72, but when added, you give positive 6. Me can't do that. Not too much something that. Listen to this story. 1 times negative 2 is negative 2. I need two numbers. When multiplied together, will give me negative 2, but when added, will give me positive 1. What two numbers are talking about there, sir? I need two numbers. When multiplied together, will give me negative 2, but when added, will give me a positive 1. What two numbers multiplied to give you 2?
1.
1 and 1.
1 and 2.
Hey,
2 and 1.
thank you, please. 2 and 1. 2 and 1. So it's so easy it is for you to find the factors, as opposed to saying 6 times 12 is 72, and you go find out, sit down and find out what 72 and this to give you 6. No. So we divide through to make the function so much easier to work with. All right. So having done that, hear what I'm saying. Recall, to factorize the trinomial above, we multiply the coefficient of x squared, which is the number in front of x squared, by the constant, the one that stands alone.
Third, to factorize the trinomial above, we are multiplying the coefficient of x squared. Come on. Oh, all right. Well, there, same difference. That works.
Yeah. All right. So this is what is happening. So we are right. So the constant is the one that stands alone. Right? So that is, it's going to be 1 times negative 2 to give me negative 2. 1 times negative 2 to give me negative 2. Right? So we now need two numbers. When multiplied together gives negative 2. But when added gives 1. And the numbers are 2
and
negative 1. And hence my factors. All right. So my factors are going to be 2 and negative 1. So why not 1 and negative 2? No, because when I add 1 to negative 2, I'm going to get negative 1, and I don't want negative 1. See what I want here in blue? positive one. Right. So this is what now happens. So what I have in blue here is a positive x. And when I do all this arrangement by putting positive 2x minus x, when I do all of this, I'm going to end up with a positive x. All right. So I end up with the same thing. So I'm not changing the equation at all. I'm not changing the equation. Now look at what happens. Look at what happens. So I'm grouping. I'm grouping. Now, agree with me. I have 3 terms. I have 3 terms. And I'm grouping. I am unable to group these 3 terms equally in 2 sets of parentheses. It means that one parenthesis will have 1, and the other parentheses will have 2, or vice versa. So that is the reason I had to split this in 2 so that I can get 2 sets of parentheses here, right? So I am grouping. Now remember, when we group and leave the middle sign out. We group and leave the middle sign out every single time. But a word of caution is, whenever you're grouping and the sign that is out is a negative sign, be careful. Be careful.
Hold on. Last. X squared plus 2x minus x minus 2 equals 0. Now we get this again.
Or we get x squared plus 2x and multiply the coefficient of x squared by the constant. And I'm going to get 2 and negative 1.
Negative 1, also you put it in the function.
Right, so it's going to become 2x minus 1x really.
1, which is 2x minus x. Same thing.
Right, same difference, right. And then now when I group, I'm going to group here, putting the first 2 right inside here. So leave out the middle sign every time. You always leave that middle sign out every single time, barring none. Leave that boy out. And then again, group the last 2 terms, x minus 2, right?
You have x plus 2, sir.
And that's why I put it in
green.
In green to show you that there's something else to be done. So remember I said to you that when that little middle sign that you leave out is a negative sign, you have to respect it. You can't call him boy, you have to call him Mr. Boy. Because this negative sign now will always flip and change this sign here. So if the sign is a positive, it's going to change to a negative. If the sign is a negative, it's going to change to a positive. So you see the sign up here was a negative 2, and it now becomes a positive 2.
Yeah.
It is because I'm factoring out this negative sign. So you have to be careful. Whatsoever sign is right here, so has to be the same sign that is right here. So the signs in the parentheses must be the same. The signs, the middle sign in the parentheses must be the same. So let's go again. Once this sign here is a negative, it means that I'm factoring out this thing. You notice I don't have a negative x inside here, so because I'm factoring out the negative sign right here. So when I multiply this negative 1 that is technically outside your seat here, so this negative 1 that is outside here, by this x, I'm going to get negative 1x. And when I multiply this negative 1 by this positive 2, I'm going to get back a negative 2. So this one here is just a dynamics that you have to go remember. We did this in foundation 1, Me they teach this in a foundation 1. Me did that.
Me did stop the foundation 1. But all right.
Yeah. But it was done. But anyway, so look at what is happening here now. I'm asking the question, what is common here to x squared? That is common here to 2x. What is common?
X.
And that's why I take out the x. And here my question to you now, what is left? So this is exactly what, very good. This is exactly what it is that we did when we are doing our factorization for the product rule. When we reach a point and we're factoring between the two terms, at the same something. At the same something, I don't know. But this one is just a little easier because we don't have multiple factors. We just have a single factor here in x. The other one we have number and X and one ugly looking something, yeah. But this one here is simpler. So I'm going to ask myself, what is common between x squared and 2x? And the answer is x. What is left? It's going to be x. Sir, why x? Because when I multiply x by x, I get x squared. Very good. And x into 2x goes 2 times. Because 2 times x is 2x. And I will say to you, what is common here? That is common here. Sir, not common. Remember, 1 is a factor of every number. 1 come like cell phone. All the baby on breast have cell phone. Everybody have a cell phone. All right? So 1 is like cell phone, always present. So 1 is a factor of all the numbers, every single number. All right? Now, is when I do my factorization, everything in the first parentheses now must pan out and match up with everything in the second parentheses. See there? X plus 2 and x plus 2. This is just a recall, you know. Oh, I did say recall. This is just a recall because this is not business calculus. I'm only refreshing your memory. So come next question. I'm going through all of this. So I'm taking my own little time before I go make my little tea. So you can digest this. Yeah, man, because don't expect me to go through all of this. It's my narrative here, so I'm write up. Because when we do this the first time, you know, don't expect me to do it for any other time. I'm only refreshing your memories. This is pre-calc. This is foundation concept as a matter of fact, not even pre-calc. This is foundation concept. Let's go. So what is common here now, that is common here, has to be the x plus 2. What is left? When I take off the x plus 2, I'm going to have x left, so I write it here. When I take off this x plus 2, I'm going to have -1, so I write it here. So this is my factorized term. Hear me now. Either x plus 2 is going to be equal to 0 or x minus 1 equals 0. Yeah, man. So when x plus 2 equals 0, I don't like how this looks.
Yeah, it looked too close.
Yeah, man, too close. All right. So if x plus 2 is equal to 0, that means x is going to be equal to -2. Sir, how you know that? I want a value here that will make it equal to 0. Good.
Yeah,
and if x minus 1 is equal to 0, x is going to be equal to +1. Whoa, sir.
When you carry it over with the 0 there, you're going to get the negative sign.
Right.
As a +2.
Good. That means, sir, this is what it is that we're talking about when you said critical values. Yes. These are known as critical x values. See them? X, and there are 2 such values. We now need to substitute these into the original function to obtain the corresponding y values to give the critical points. That's the point I was making. Remember, you know, I'm giving you this narrative here so that when you're reading, you can hear your teacher with you nonetheless in his absence. When I'm doing other questions, you're not going to see these narratives. So I'm saying to you, the x equals -2 and the x equals 1 is real Rockstone. A 624? Jesus.
Yeah, man, time ago, sir.
Jesus. So it's really, but I don't have a problem with just spending one question because at least I'm going through the question in its entirety. So remember now, it's that these are my critical values, not my critical points. Because a critical point has both an x and y value. You're not seeing a y value right here, so yet. You're not seeing a y value. So these are known as critical x values. So in order to get the y value, I have to now put x equals -2, the one here, into y, which is my original function, all the way up here. So let me just copy this to carry it back all the way down here. So into y, all the way. Okay, so you have it as a recall. So into y, all the way down here. All right. So watch me. Anywhere in the function, similar to when I'm calculating the y-intercept. Anywhere in the function I see x, I put 0. Anywhere in the function I see x, no, I'm going to put 2. -2, that is. So I put the -2 here, so where x is, I put the -2 here, so I put the -2 here. So -2 cubes is -8. And -8 times 2 is -16. -2 cubes is 4, and 4 times 3 is 12, right here, so. And -2 times -12 is a +24, right here, so. -7. -16 plus 12 is going to be -4. -4 plus 24 is going to be +20. And 20 minus 7 is going to be equal to 13. So the y value is 13. So watch this. If x, when x is -2, y is equal to 13. So that's why I have my critical point to be -2, 13. So this -2 is married to this 13 based on this question. There is no other point, Y value, that can be engaged or even wedded to the -2 but the 13. All right, the 13 is going to be the one that is going to be with it. Similarly, I have another critical value, which is x equals 1. Anywhere into the function I see x, I'm going to put 1. Watch me again. 2 times 1 cubed, right here so. 3 times 1 squares, right here so. -12 times 1, right here so. -7. 1 cubed is 1 times 2 is 2. 1 squares is 1 times 3 is 3. -12 times 1 is -12. And I cap at my -7. 2 plus 3 is 5.
5.
And 5 minus 12 is -7. And I'm adding a -7 to that, I'm going to get -14. So when x is equals to 1, y is equals to -14. So my critical point is going to be 1, -14. These 2 points are very, 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 very important. They will determine the nature of my turning points, where my turning points go. If them turn up, them turn down, because I did not get any equals 0, meaning that I have I don't reach your state in any event. But I need to know, is this a maximum? Is it a minimum? Is it a saddle point? Same question. Is this point a maximum? Is it a minimum? Is it a saddle point? So let's go. Now it is that we're going to be, sorry, let me tell you why I'm going to do that next. So the question says, determine if the critical point or points is our maximum or a minimum. So the question tells us that we don't have no saddle point in it. We either have a maximum or a minimum, or just a minimum alone or a maximum. All right. So now, so this part 3 here is a part 3 here to the question, determining the nature of the turning point. And I'm saying to you that another name for turning point in some of the other questions would be critical points. Another name could be stationary points. All right. But in this question, they gave us critical points. Sir, why are you being very specific about that? Because I don't want to see the other question and then ask for a different form and you get confused. So there are 3 things that they can ask for: stationary point, critical point, turning point. All right. So now, when x is equal to -2, remember, I now need to look at these individually. So you go to the doctor and the doctor isolates up the problem, and the doctor now have to zoom in on the area that can find the problem with, right? So we are doctors in our respect. So we now need to look this definitively now at the -2 and the +1. So when x is -2, we're going to start with -2 first. Recall, dy by dx is equal to 6x squared plus 6x minus 12. Hear me now. Please note, to investigate the nature of the stationary points, we will use the first differential and not the original function. What do I mean, sir? We have to differentiate. There's something here. Oh Lord.
For something that.
Yeah. All right. All right. Hold on.
Investigate the nature of the stationary point. We will use the first differential.
Okay. So there are 2 methods actually, and I use a second method instead of the first. Let me just look at the other question that I did, which are the methods that I used. Let me just check to see which are the, okay, so I use it d2 by dx squared. Okay, let me use both methods. Let me use both methods. All right, so, I have enough time. Let me use both methods. So remember up here, right up here, to determine the nature of point, I said that you're gonna use the first differential, differentiate it a second time to obtain the f double dash of x. This is, so this is method 1. Remember I said right here, so I'll soon show you the graphical method. Hello? Anybody?
Yes, sir. Yes, sir.
Right,
We heard
right, right. So I can now tell you the graphical method is my preferred method because at least you see the shape of the graph while you're doing the graphical method. So let me just amend here and call this method 1, method 2. Method 1. So there are actually 2 methods. There's no, it's not an error. There are 2 methods, but I just didn't do the method 2. The other method. All right. Method 1, method 2. So to classify the nature point, I have 2 methods. I think though the graphical method is my preferred method, a lot of students prefer this method because it is easier. But I'm going to show you both methods. So allow me to use a graphical method for this one, and I'm going to amend the steps right here. Instead of saying so show you that, I'm going to amend the steps right here. Let me just save this as I go along. All right. Okay, so let me just pick up now. All right, so okay, so let me go through the graphical method here. Didn't want to do it at this point, but nonetheless. All right, so the graphical method says, and I want you to pay attention here, please. Not difficult, but I need your undivided. So when I'm looking at my stationary points, and I want you to hear me. I'm looking at my stationary points, but when I look at, because I'm doing single variable, I'm really not interested in the y value. I'm only interested in the x value because I'm talking about a single variable point, single variable function. When I'm talking about a multivariable function, I'm going to be talking about both points, both x and y values. All right. So with that said, I'm looking only at x equals -2. So recall dy by dx is equal to 6x squared plus 6x minus 12. So where we got that from? Remember, we got our original function, and then we would have differentiated. Let me just copy so that anything going through your headspace, you would have. Recall that, then, so recall y equals all of that, and then sorry. So recall what I'm recalling are my functions. Recall y equals all of that, then dy by dx is equal to that. That's the first derivative. So I'm recalling those 2 stuff. All right. So now that you see what it is that we have. So please note to investigate the nature of the stationary points. We will use the first differential and not the original function. All right. So we need to investigate the left-hand side and the right-hand side. Lord have mercy, sir. We'll come back to the limit something again where we have to investigate the left and the right. Absolutely. Absolutely. So let's go. So, and also we need to look at the middle too, right? So we're looking at the left-hand side. So if this is x equals -2, we need to look at the left of -2. Remember, when we talk about left, we talk about less than. And when we talk about right, we talk about greater than. Anybody remember that?
Yes, sir.
Yes, sir.
Very good. So when we talk about left, we talk about less than. When we talk about right, we talk about greater than. All right. So the concept still comes back here. So left-hand side, see here, is less than. Right-hand side, see here, so is greater than. So what this says now, we need to find a value that is less than -2. Give me a value that is less than -2, please. Give me a value less than
-2, -1.
If I clap, you see now, Emilio.
-3.
-3.
Emilio. Emilio. -1 is a bigger number than negative.
Bigger number. Oh, sorry. I forgot to say back way. The other way I go. I go back. All right.
Jesus, have mercy. Lord help him, save him, Jesus.
Yes, sir. -3 is the lesser value.
Tashana.
Sir, I am here.
I know what this means.
Yes, sir.
Okay, thank you. I'm just saying. Good. So -3 is going to be less than -2. So you notice I put in -3, for example, inside of this. Remember now, it is the differential that we are working with and not the original function. We're working with the first differential and not the original function. So is this now again substituted in? Sir, why? Because dy by dx represents the slope, and we are now investigating the slope of the curve. All right? So anywhere into the differential, I see x. I'm putting in -3. Watch me. -6 times -3. See, okay, so bam. 6 times -3 squares plus 6 times -3 minus 12. Let us work it. -3 squares is +9. And 9 times 6 is 54. And 6 times -3 is -18. And minus 12. When you work out all of that, you're going to get +24. You're going to get +24. And that's why I have it as positive. The number 24 doesn't mean anything to me now. I just need to know at this point whether or not it's positive or negative. So I'm going to get this to be positive. So when it says less than, it is positive. Now, see here, this is the positive section of the graph. Now, Tashana at the start of the class, don't be quiet now.
I'm listening, sir. I'm looking and listening, sir. I don't think I've seen any line that shape though.
Yeah, man. Based on what I was just about to say, based on the conversation that Tashana had at the start of the class, when it is that we're looking at the different shapes of the lines, you know, the lines that are positive, the lines that are negative, the lines that are used, you know, the parabola, etc., etc. The positive slope is when it goes up here. So start from bottom to top. Positive slope is starting from bottom to top. Put it this way. Emilio come from humble beginnings. But
reach at the top.
Reach at the top. That means that him step up in a life, talk through, don't.
Yes, man.
Good.
Cash pattern,
we're not play them something there. And then and then now we think about the man or the woman who bonds into wealth, but because them don't have much ambition now, them waste them something and them up on top, you know, and them go all the way down. It means that to them resources running out or building up.
Depleting.
That's why this go down. Right? So that's why this line from bottom to top is positive, because you start from the bottom and you move all the way up to the top. It means that you are, yes, hon.
You know, now that I look at the shape, I'm remembering that we had to do one question with this particular shape line. So explain that when you're going up, like you're going somewhere, you're moving forward towards it. When you're leaving, it becomes negative. So
absolutely, yeah. absolutely. Right. So this piece here, this positive piece, is telling me that I'm moving in a positive direction. So I have started the shape of this graph, and this graph is moving from bottom to top. This piece is positive. So this piece here, so, is representing my positive section. But what's happening now? Is when x is equal to 2. Is when x equals 2. More you work the one for me. You know.
The mirror thing, sir.
Huh?
The mirror thing, the reciprocal, I call it, I think. Inflection.
Yes. No, not the inflection. Not the inflection. But this thing here.
It's not the reciprocal, sir.
No, not the reciprocal. This one here. I'm just trying to put in this. All right. Try putting 0 and tell me what you get for me, please.
All right.
Put in 0, sir.
Sorry, try putting 2, negative
2. Oh, come just wonder we are talking like you have 0 already.
Oh my goodness, -2.
All right.
At the time you look on, you know, and I'm here try.
Stop paying attention to the time, man.
I see me, so.
I'm going to just go through. So
Alright. -2 times -2 and positive 4, 4, 4, 6 is 24 plus same thing. 4, 6 is 24 minus 12. So 24 and 24 are 48 minus 12. That are 24. What? No, not 24. No. 24. 2 from 8 left 6. 4 from 8 left 4. Sorry. And 2 from. Yeah, 24. No, wait. Lost again. Need to start writing down things.
Sir, what are we supposed to do?
Check to see if what happens when this is -2.
From 36, sir. Positive 36.
What?
Wrong?
-2 squares is 4, and 4 times 6 is 24, don't?
Yeah, plus.
Positive 24, right?
Oh, positive 6 minus -.
And then
no, me I do it wrong. I do it wrong. I do it wrong again. You see it, I put power with it in the second one and no power another day.
Yes, Shana.
It's in the, the original function, right, where we have 6x squared. You change out the x, the -2. Okay.
Not the original function, please. The differential.
Come on. At 0, that 0 for true, sir. You're right.
Oh, the differential, sir?
Yes, the differential. Yes, please.
Okay.
So what 24 minus 24, which is 0, minus 12.
Okay.
No, lie. 24
no,
minus
24 minus 12 minus 12.
Yes, yeah.
Right, so it's 0. So I didn't put it here but I want to put it here now to show you that this piece here is always going to be 0. When you find it exactly, so when you find the differential, this piece will be equal to 0, right? So the middle piece is going to be equal to 0. No, right here, so this is a 0 part because nothing now happened, so it's 0. Let me pause right here so and just remind you of foundation concept 3 when you are doing the distant time graph. Emilius accelerated uniformly to 5 meters per second squares. Then he was
where the car stop on the roads are not moving, it just it.
Right, but guess what now? Remember, time is continuous, so it still have to
run. The time still run, but it's not going up or down. Just that line going straight across.
And that's exactly what it is. So time is continuous. So he's not going anywhere because in part the car, a roadside. Don't ask me about my roadside, but in part the car roadside, and please don't answer Emilio. In part the car roadside, and that's why it's still like that. Time is continuous, so that's why the time is running. But after him gets stood up now and kiss him teeth, him said, "Sure, I'm going to man," and that's how he started to decelerate and go on. So this is really looking like a distant time graph. All right. So let me just pause right here so I'm sure you know. You see the importance of foundation concept 3 with the business calculus? It makes a lot of sense because we're connecting the dots and showing you the connections of the things that we have been doing. So
and also giving us some new names for some stuff.
Very good. So like when we talk about vertex in foundation concept 3 is really turning point, is really critical point, is really stationary point. Right. So we have different we have different ways of calling it. When you're calculating we call it now, a over magnitude x plus h all squared plus k is really a differential that you're doing. But we nobody tell you that. So we have different things that we kind of introduce to you at that stage, and then when you pass that stage, we can come and say, all right, remember when we used to call it down there, so it's really this way and call it now. So just showing you the connections, because a lot of students will say to me, sir, why would they have to do this? This now not relevant to that. Now you're seeing the connection, the connections with the foundation concept 3. And as a matter of fact, when we do the factorization, you see foundation concept 1 and 2 inside of it, and 3. All right, so those come in play. All right, good. Now the other part, is the right-hand side. We need to look at the right-hand side. And looking at the right-hand side, you see, looking at the right-hand side, what is to the right of -2? To the right of -2, sir? No, 0. Yeah, man. Yeah, man. You could say -1 too, you know, but I work smarter, not hard, because I work -1, I have to work with all of that. When I put in 0 now, it's easier for work out because everything got to 0 with the exception of the term without the x. So I know I have a -12. So that becomes negative. So watch what is happening here now. Beautiful. Very, very nice. This positive, and I'm going to see if I can label this graph. This positive is this. This 0 is right here, so.
Or it's still, time still going.
Right. And this negative is this.
It's where you have to go back, yeah, turn back.
So it's just like me I drive on the highway at 100 and I just cruise at 100 for a while and then me decelerate from the 100, go back to about 50.
It's same one. It's same one. It's same one. It's same one. But watch this now.
Sir, I think I owe you an apology. You said that I was quiet for a while. You know, I've dropped asleep, sit down, same place, looking at the screen, and I hear my name and I open the mic.
No, we should charge you.
Sir, I am paying attention. I'm just.
We should charge you. We should charge you. All right, let's go. Let's go. And then now, what should I say to you, Lord? All right. Please, don't anybody laugh at me, see? Me and them have it out. A local maximum. Why? Because the shape of this sketch looks like
an N for negative.
For negative. Don't it look like one N right here? So talk truth.
It looked like a deflated N, like somebody had to sit on my
I end up in out that shape. Yeah, man, I end nonetheless.
You know,
look like a frown, sir.
No, Emilio come from country, you know. He's from him said away there, and he's not a Kingstonian. He come from country, behind Jesus, turn right and then left, right? Yes, Emilio. But you see the point of what I want you to get from it, guys. I did this graph this way just to bring across the foundation 3 to show you my positive versus my constant versus my negative. All right. And then now, if you look at the N, you can see going up is positive. There is a flat piece on the N, and then there's a piece that goes down, right? I don't think I could be very effective in showing what I really wanted to show with the N, so that's why I put it like that. But the point though is that it shapes downwards, all right? So, and remember now, N for negative, you can't go wrong. Can't go wrong. Threshold N, yeah, threshold N. Good. So let's move. So we're looking at, so we've done the x equals -2. Now we need to look at the x equals -1, and it's the same procedure. We can't go through quicker this time. X equals -1.
I want that, not -1.
Right. I just said to say if you were paying attention. So x equals 1.
I'm not asleep. I might asleep, but me not asleep.
Yeah, man. So x equals 1. So I'm going to look to the left of 1. When I look to the left of 1, geez, could I get 0? Don't. So yes, yeah, man, and that's why I put in the 0 right here.
To the left of 1, sir.
To the left of 1.
0. Yeah.
Right, good. So remember, you know what? Because
put it down there, sir.
Yeah, man, put it down there, sir, because me no want nobody go forget this. So this recall here, so we're using the differential and not the function. I'm going to put this down here.
I've got to take out that. Yeah, I've got to take out that part.
No, I'm going to put it, okay, you know why? I don't want nobody make no mistake with the stuff. Peace. All right? So now we have the stuff. Again, now we're looking at x equals 1. And recall, this is a function. When we differentiate this function, we get this. But we're not interested in the function anymore. We're interested in the differential. Now, so we put in 0. So this is going to be 0. 6 times 0 squared plus 6 times 0 minus 12. This is a simple minus 12, eh? And trust me, when you put in x equals 1, you're going to get 0.
Yeah.
And then now when you move to the right of 1, blow out 2.
The right of 1, sir, yes, it's 2.
Good. So 2 squared is 4.
4 6 is
24.
Plus 6 is 12 minus 12 is equal to a positive
24.
24, sir.
Very good. So this is positive. So remember, I only put the numbers here because I want to show you, that we're working it out. But at this particular point in the question, I am not interested in the 24. I'm only interested in it being positive in this case or negative. So watch me now. The reverse is true. Negative, you're stepping down in life. You're going down. 0 is always horizontal. And then positive is when you're stepping back up. So this looks like a U. It's a local minimum. The shape of the sketch looks like a U for positive. All right? A threshold U. So it looks like that. And that's exactly what it is. It don't write this, So we know that we have a local maximum and a local minimum based on the question that was asked.
So sorry, that's what you meant by, because I already saying local maximum and local minimum before we start to those. And I was wondering if it's the actual parabola shape. No, it's just a flattened section. All right, sir.
Yeah, no, but it's still a parabola,
yeah, but it's just an ill shape, sir. Like somebody sitting on the deflate, like when your tire puncture and just flat down one side. Yeah.
Same as so. It stretch out. Yeah. But the point is taken. As I said before, please appreciate what it is that I did right here. I wanted to show you the journey for you to see here, but it's really an N. It curves down, so it looks like an N. And this one curves up, it looks like a U. All right? And then now, that's the end of the question.
That one is the minimum, the local minimum.
The minimum is the one that looks like a U. No, it says to sketch the graph.
The graph.
I think I did. I made an error.
You found the critical point there.
By doing the point of inflection. Sorry, go ahead.
The critical points, sir. Those we're sketching the graph. Those are the points that we use as well, sir.
Right.
Positive 24 and.
So hold on. The point of inflection.
It never asked in the question, but because I did it.
No, but yeah,
I'll put it in. No, I'll put it in.
That's what I say. Add it.
Yeah.
That is a step we need for note. Another time you can do that.
Determine
point of inflection.
Determine the point of inflection. The point. All right. So since I did a question there, let me do. Oh, this is going to be 5.
Change that to 5. Yeah.
All right. Thanks, Papa. What would I do without people like in the class? All right.
Make sure you see the document, please.
Oh, yeah, man. I just see it a while ago. Thanks. All right. Okay. So let's go. We have 7 minutes. We can do the point of inflection within the 7 minutes. Remember now. So if dy by dx is equal to 6x squared plus 6x minus 12. Remember, the point of inflection, we have to find the second derivative. Remember, I said to you, in order to find the point of inflection, I must find the second derivative.
The second derivative, sir. So I have 6 2's 12x plus, and that 1x right there becomes 6 alone.
Very good. So I have 12x plus 6. And then please note that we are differentiating the first derivative a second time in order to obtain d squared y by dx squared. All right, good. Then I'm going to put d squared y by dx squared to be equal to 0. To be equal to 0. So this 12x plus 6 is going to be equal to 0 right here. So the 12x plus 6 is going to be equal to 0 right here. So
I see it, sir.
And then we're going to have 12x is equal to negative 6. And then divide both sides by 12.
Sir, how you get that? But we learned that from in the first section. Because where the x is a carry over the 12, negative 6 minus 12 is still going to give you 0.
Very good. So my x is going to be equal to a half, negative a half. And we are going to put x equals negative a half into y. And note that we are substituting into the original function this time, not the differential. So these are some of the things that you have to pinpoint and know which to put it in. All right. So we're going to substitute it into the original function now. You see, because I am teaching you this thing here. Me want, and if we catch it right here, so that's why I'm putting in the original function. So anywhere in the function I see x, I'm going to put negative a half. No, a calculator can do this pretty easy for you, right? If you have a good brand calculator, it can be done pretty easy. So anywhere in the function I see x, I'm going to put negative a half. Anywhere in the function I see x, I'm going to put negative a half. So this is going to become 2 times negative a half cubed plus 3 times negative a half squares minus 12 times negative a half, minus 7. Negative a half cubed is negative 1/8. Negative a half squares is a quarter. And of course, negative a half to the first power is negative a half. And 2 times negative 1/8 is negative a quarter. And 3 times a quarter is going to be 3/4. And negative 12 times negative a half. When I multiply 2 negative numbers, I get a positive number. And 12 times a half is going to be 6. And my negative 7 comes back. And when I have negative a quarter plus 3/4 is going to be a half, and then 6 minus 7 is going to be negative 1. So I'm going to have a half minus 1, which is equal to negative a half. So x is equal to negative a half, so is y. So I'm going to have negative a half, negative a half.
But sir, even without working it out, you know, for instead of negative half, you know, it's going to be the opposite.
Yeah. All right. But in some cases, though, the x value is not the same as a y value.
Okay.
Right. The x value is not the same as a y value.
Because I'm looking at them, x and y are both negative a half.
Right. But in other cases, what I'm saying to you, when you're finding the point of inflection,
if you work out the function.
Right. The function determines what happens, because sometimes you can work out the point of inflection. And it changes, and it's different. It's a different.
Essentially, we're trying to find h, right, sir?
Right. Look here. See here. Determine the point of inflection here in this question, and there's 2 different values you get for the point of inflection.
Yeah.
Right.
I see.
So not because we have negative a half, it means that every time it's going to be the same value. No. The values change as the question changes. All right. And then in my last 3 minutes of the class is just to bring across some points, just to highlight some stuff, because I will have to definitely do the graph part with you again. The calculation part is fine. Yeah, but let me
part, sir.
Let me just show you something here. Point of inflection. Let me just bring up this a little bit, because no, it's all right. I know what to do. My critical points. I'm just reminding you something here. My critical points are negative 2, 13 and 1, negative 14. Negative 2, 13. Negative 2, 13. Trust me, is right here. So negative 1, negative 2, negative 3, negative 4, negative 5. You can see that? Negative 1, negative 2, 13,
yes,
5, 10, 11, 12, 13. So this is a negative 2, 13. And then the 1, negative 14 is this, because if this is 1, 2, 3, 4, 5. And then we could check 14 now. This is negative 5, negative 10, negative 11, negative 12, negative 13, negative 14. All right. So that's what we get.
Essentially, this line, this S line, is what you're calling the sexy line, I think.
Yes, ma'am. That's my sexy graph.
Okay, now I have a name for it, so.
Yeah, man, that's my sexy
graph.
Because
to me, it look like a line that's continuous, and one section on the left is a maximum point, and the one on the right is a minimum point.
All right. Like an actual N.
It looks like an N, yeah, but and you're correct, Tashana. Yes, you're correct. It looks like an N, but guess what? So Tashana is saying that this is a maximum point. You see, it turns down.
Yeah.
Right.
The titty point up at the top up there is what she called it in class, and yeah, yes, sir.
So you have a teacher who also called it the titty point too.
Yes, sir. I'm not calling her name though. Miss
I thought I was the only one who is it because I'm being recorded now?
Yes, sir.
I have to behave myself because
this recording. Sir.
Yes, man. So I try as best as possible, right? So yeah, man.
Your next partner in crime, sir.
See me, so. All right, let's go, guys. So we have no more minutes left, but just to show you here. So this is going to be you remember when we did this point here, we got the negative 2 value to be N and negative. See it here, so it come up on the graph now. The negative 2 point is a N. So you see the N right here, so, and the other point now is the U, right? And then now the point of inflection now is going to be the midpoint between this up here, so, and this down here, so. So along this stretch here, so, right here, so, this stretch right here, so, between the maximum and the minimum, is where we're going to have
twister.
Right, is where twister. We have the negative a half. So negative a half, negative a half. Going to be some negative a half is somewhere right here, so. And negative, so somewhere right in here, so. Somewhere where you see that is going to be the point of inflection. Means you can twist the graph right there, so. Yeah, the graph flexible right there, so. This and this alone, it inflects right there. All right, guys. Thank you for paying attention. I'm going to send this off to you. Please, you must find the time to go through this stuff.
Practice.
All right.
Sir, I'm going to try. Thank you, sir.
Take care, guys. So cool.